This is Geometry, Chapter 8, Section 2, in which we will study the Pythagorean Theorem and its converse. We've been using the Pythagorean Theorem quite a bit already this year, but now we're going to formally discuss it. Its lengthy, wordy form says that in a right triangle, the sum of the squares of the lengths of the legs, that should be of the legs, not or the legs, is equal to the square of the length of the hypotenuse. That's the wordy way of saying, if we put c in the hypotenuse slot, a squared plus b squared equals c squared. So this is one you've known for quite a while. Now we're going to do some things with it that you're not used to, but that's beside the point. We'll get to that as we go. First we'll do the part that you are used to. Okay. They want us to find the missing side using this right triangle over here. So we have A, B, and we're looking for C. Plug into the formula. Arithmetic, collecting up, and then take the square root, and we find out what C is. Okay. And we can use this also to find one of the legs. In this case, we're looking for B, so we'll plug into the A and the C. Arithmetic, subtract over, and then take the square root. So this part of it, you're comfortable with. You've done it 14 trillion times by now. That might be a slight exaggeration, but done it several times anyway. Now, another idea that comes from the Pythagorean theorem is the idea of a Pythagorean triple. It's a set of whole numbers, and they say non-zero just so you don't think about putting in a zero for a side, but a set of whole numbers that satisfy the Pythagorean theorem. If you look on 548, you've got a table that has a list of common Pythagorean triples. You've seen along the way when we've done some problems, I've just looked and told you, yeah, that's right. And how in the world do you know? Well, because I've got these numbers memorized. I've used them so many times that I know 3 and 4 will lead me to 5 in the Pythagorean theorem. 5 and 12 will lead me to 13. If you can recognize these numbers, it will save you a lot of trouble because then you don't have to work through it to get to what the hypotenuse is or whatever. Now, if you don't recognize you've got a triple in front of you, that's okay. You can still use the theorem. It will still work. It's just a possibility that it could save you some time. So I might consider putting some of those numbers onto my note sheet. Just me, though. Now, we have 3 theorems that take the Pythagorean theorem and go backward with it. Okay, remember the given part of the Pythagorean theorem. The hypothesis is you have a right triangle. So in the converse, we're trying to decide what kind of triangle we have. Okay. The actual converse of the Pythagorean theorem says if a squared plus b squared equals c squared, then it's a right triangle. Well, that's great. If we just need to know, is it right, yes or no, we can just use this and see if a squared plus b squared equals c squared. If it does, then we say it's a right triangle. If it doesn't, then we say it's not a right triangle. But what kind of triangle is it then, if it's not a right triangle? Well, that's where theorems 8.6 and 8.7 come into play. 8.6 says if c squared is less than a squared plus b squared, then you have an acute triangle. 8.7 says if c squared is greater than a squared plus b squared, then you have an obtuse triangle. Okay. Again, I didn't say exactly what's on the screen here. I substituted in A, B, and C for what they're talking about. And if you didn't catch which way I said it, that's okay, because here, as you can see on your note sheet, we have a summary of those three theorems. A lot of times mathematicians get paid by the word, so I've boiled them down for you and gotten the essence of what you're really interested in. If c squared is less than a squared plus b squared, you say it's an acute triangle. If c squared equals a squared plus b squared, you say it's right. If c squared is greater than a squared plus b squared, you say it's obtuse. Okay. These three statements are what those three theorems are talking about. I just, like I say, I boiled it down for you and got to the essence of it. So let's classify this triangle, and they throw in this if it exists part. Remember we did the triangle inequality, two sides together have to be greater than the third one. They're going to throw a few of those at you, so make sure you check and see if it even exists first. 7.2 plus 13.8 is 21. 21 is greater than 20, so the triangle exists. So we're good to go there. Obviously 20 is the biggest one, so 20 has to be C. 20 squared, and we're going to compare that against the other two squared. 20 squared is 400. If we square the other two, we get these two numbers, according to my calculator. Add those together, 400 is greater than 242 and change. If c squared is greater than, then we say it is an obtuse triangle. Okay. Work out c squared, work out a squared plus b squared, and then compare. And then this little 3-sentence summary right here will tell you what kind of triangle you have. As always, if you had questions along the way, hopefully you wrote those down, bring them on in with you, and we'll see you in class.